All right, in this video lecture, I'm going to cover section 10.2, second stage, the Krebs cycle. So, if I'm just gonna backtrack here, we went through glycolysis, okay, where that is the first step in cellular respiration. It occurs in the cytoplasm of the cell. We are going to take glucose and cut it in half and end up with 2 molecules of pyruvate. To do this process, you have to burn a little bit of energy and then you make some energy. So the net gain is 2 ATP. And when these atoms and molecules are being rearranged, electrons and hydrogen gets picked up by NAD plus to become NADH. So there are 3 products to glycolysis that I want to stress. 2 molecules of NADH, 2 molecules of pyruvic acid, and it says 4 ATP here, but we use 2, so the net gain of ATP is actually 2, because 4 minus the 2 that you use to start the process, you get 2 ATP. Now, we are going to talk about the fate of pyruvic acid. Okay, if oxygen is present, it is going to move on to the Krebs cycle, which is in the mitochondria. So we are going to go through the second stage of cellular respiration. So this is where pyruvic acid is going to be broken down into carbon dioxide in a series of reactions. And we're also going to create a little bit of ATP, but not much. But the main product here, the one that's really going to help us make a bunch of energy at the end of cellular respiration or aerobic respiration, are energy carriers. Okay, and I know that's not really emphasized in this diagram, but this dashed arrow is basically electron carriers. We are going to generate so many electron carriers that are going to be used in ETC to make a whole bunch of ATP. So let's dive into it. Okay, so where are we? What's the location? Hey, we are now in the mitochondria. Okay, specifically the matrix of the mitochondria. And now I'm going to ask you, what are the reactants? Okay, now remember, the definition of a reactant is what goes into a process. So when I'm looking at this, all right, I got pyruvic acid, also known as pyruvate, but it's going to come in, all right? I see this arrow, it's entering this process. So it's not going to make me, shoots. Crap. 1 second. Let me see if I can lock this. Okay, there. One reactant is going to be pyruvic acid. It's going to enter the process. And now I'm going to look for arrows that go into the process, okay? Oh, NAD plus is also going to be a reactant, okay? It's going in. I follow it. Okay, we got some acetyl-CoA here, but, it's kind of an enzyme that just gets reused. Looks like we're going to make some citric acid. That comes out. That's not a reactant. I'm looking for products. Oh, sorry, I clicked the wrong one. Dang it. You have to find the right spot. NAD plus. Oh, some more NAD plus. Oh, ADP, something called FAD. We'll talk about that. Oh, NAD plus, and I think I hit all my blue circles here. Okay, so now the products. What comes out? Okay. Oh, I see CO2. Oh, I see an energy carrier, NADH. I see another CO2. I see NADH. I see CO2. I see NADH. I see a little bit of energy, ATP down here, FADH2, NADH, and I lost the CO2. So now I have these 2 carbon molecules, and that one carbon has turned into carbon dioxide. And then down here, oh look, I have this 1, 2, 3, 4, 5, 6, but I cleave and there's only 5. So every time I cleave off a carbon, so now I have 5 and it turns into 4, I create a molecule of CO2. All right, so we are in the matrix of the mitochondria. What goes into it? Well, 1 pyruvic acid, according to the diagram, 4 NAD pluses, 1 FAD, 1 ADP. And then from those reactants, I get 3 molecules of CO2, 4 NADH, 1 FADH2, and 1 ATP. But remember glycolysis, okay? Sugar is a 6-carbon molecule and pyruvic is 3. So how many pyruvic acids do I really have here? Oh my gosh, I actually have 2 pyruvic acids. So my 4 NAD pluses become 8 NAD pluses. My FAD becomes 2 FAD oh, sorry, I shouldn't have put that plus there. 1 ADP turns into 2 ADP. So now my products, I also have to double them. Instead of creating 3 molecules of CO2, now I have 6 molecules of CO2. 8 NADHs, 2 FADH2s, and 2 ATPs. So these are all my products for my 2 pyruvic acids. Because glucose is, I took glucose and I split it in half, so I ended up with 2 molecules, and they're called pyruvic acid. So the steps, pyruvic acid is going to pass through the membranes of the mitochondria, and during this process, we are going to cleave off a carbon. So my 3 carbon molecule becomes 2. And as a result, some electrons and hydrogen get lost, and I end up with one of the electron carriers. It also gets shuttled in by acetyl-CoA to the actual Krebs cycle. And then once it drops off that 2 carbon molecule, it goes back to pick up another 2 carbon molecule. So all it does is it kind of escorts or shuttles it into the Krebs cycle. Okay, so acetyl-CoA shuttles the remaining 2 carbon molecule to the Krebs cycle, where it's going to bond with a 4 carbon molecule called citric acid. The Krebs cycle is also known as the citric acid cycle, because that is the first molecule made in the Krebs cycle. So this 2 carbon molecule plus 4 equals 6, and that molecule is called citric acid. And citric acid gets broken down in a whole bunch of steps, right? So I already talked about this up here. Here's my citric acid. Oh, I'm going to cleave off a carbon, so 6 carbon molecule becomes a 5. But every time I cleave off a carbon, I'm going to generate a carbon dioxide molecule and an electron carrier. And then I cleave another one off. Look, CO2, NADH. And then down here we get some rearrangement, the cleaving of phosphate to produce 1 molecule of ATP from that 1 molecule of pyruvic acid. And then we get some more rearrangement, and FADH is another energy molecule. It carries a lower amount of energy, but it is an electron carrier, and it does get used to make ATP. And then later on in ATC, I should say. And then some more rearrangement, and I create my final energy carrier here, NADH. And then repeats, okay? So citric acid is broken down. I produce CO2, I produce ATP, and a whole bunch of electron carriers. And that is what happens in the Krebs cycle. So from the Krebs cycle, really it's all about making electron carriers, because those electron carriers are going to be used down in the 3rd stage of cellular respiration, where we are going to make a whole bunch of ATP. So from glycolysis, how many ATP did we make? We've only made 2. Okay? And from the Krebs cycle, how many ATP molecules have been made? Well, 2. So 2 plus 2 is 4. 4 ATP. That is not a lot. Okay? And so the 3rd stage of cellular respiration, where you have the presence of oxygen, you can really make a whole bunch of ATP. So that does it for this lecture on the Krebs cycle. Next lecture, I'll talk about how we use those electron carriers to create, like I said, a whole bunch of ATP that our cell can use.